Welcome to the session. I am Mrs. R. Shigila Devi, Assistant Professor in Department of Computer Science and Engineering at Rohini College of Engineering and Technology. In this lecture, we will explore Unit 1, the Machine Learning Life Cycle. This topic provides a complete understanding of how a machine learning project evolves from the initial problem identification stage to model deployment and monitoring. The machine learning lifecycle represents a systematic process followed in developing machine learning solutions. It includes a sequence of phases such as data collection, data preprocessing, model training, evaluation, deployment, and continuous maintenance. So, understanding this life cycle ensures efficiency, reliability, and better performance of AI-based system. So, in this lecture, we are going to see about all those things. So the first phase in machine learning lifecycle is problem study, where we identify the business objectives and define the desired outcomes. The next phase is data collection, which involves gathering relevant data from the different sources like databases, sensors, or APIs. In data preparation, the collected data is cleaned, transformed, and divided into training and testing sets to ensure the model accuracy. Finally, in model selection, we choose a suitable algorithm based on the type of problem classification, regression, or clustering. Next, once the algorithm is chosen, the model building and the training phase begins, where the architecture is created and trained using the training data. After that, in the model evaluation, the model's performance is tested using unseen data and key matrices such as an accuracy, precision, and recall. The model tuning phase involves optimization of hyperparameters to achieve better performance. So the trained model is then deployed into production system, and finally in the monitoring and maintenance phase, the model's behavior is tracked over time and retained as done where the performance degrades. The types of machine learning algorithm. There are three main types of machine learning algorithms: supervised, unsupervised, and reinforcement algorithm. In supervised learning algorithm, models are trained with label data. In unsupervised learning, the models are explore patterns with labels, and reinforcement learning is based on reward and feedback from the environment. So each type plays a vital role in depending on the nature of the problem. So first is supervised algorithm. Supervised learning uses labeled datasets where both inputs and expected outputs are known. It aims to map the input features to the output targets. It can be further divided into regression, which predicts the continuous values like house prices, and classification, which predicts the discrete outcomes such as whether the email is spam or not, etc. So the supervised learning is one of the most widely used technique in real world applications. Next is unsupervised learning. In unsupervised learning, the models are learned hidden patterns or structures in data without predefined labels. The common technique includes clustering, k-means, which groups the similar data points together, and associations, which identifies the relationship among variables. In this approach, it helps in market segmentation and recommendation system. Next is reinforcement learning. The reinforcement learning is based on the concept of agents interacting with their environment. The model learns by trial and error and receives the feedback in the form of rewards and penalties. For example, in an automatic driving of car, the car learns how to steer safely based on positive and negative feedbacks from its environment. So this type of learning is used in robotics, gaming, and real-time decision making. So when you summarize the machine learning lifecycle, which covers all the essential phases from the problem identification and data collection to model training, deployment, and maintenance, understanding these phases allows the engineers to build more accurate, efficient, and reliable systems. In the upcoming units, we will explore each phases in greater detail with examples and practical demonstrations. Thank you.